We're just going to talk a little bit about the solubility of hydroxides before we go on to talk about using precipitate reactions to produce salts. Okay, so the hydroxides can be classified as soluble, slightly soluble or insoluble. So the soluble hydroxides are the group 1 elements. Okay, they form soluble hydroxides. So if you add sodium hydroxide, potassium hydroxide, lithium hydroxide if you want to water, stir, then they will dissolve and form an aqueous alkaline solution. The slightly soluble hydroxides are the group 2 elements, for example magnesium or calcium. Okay, their hydroxides will partially dissolve in water, producing an alkaline solution which is weaker than the alkaline solution produced by the group 1 elements. Okay, so and the hydroxides that are insoluble are the transition element hydroxides and aluminium hydroxide, for example. And the transition elements, as you know, tend to produce coloured salts, and their hydroxides are coloured too, with copper hydroxide blue colour, iron 2 hydroxide this muddy sludgy green colour, iron 3 hydroxide this rusty brown colour, aluminium hydroxide is white, zinc hydroxide is white. So you'll probably remember that these hydroxides form the basis for identifying metal cations when a weak solution of sodium hydroxide is added to a salt solution. Now you can look at that process more closely if you go to the section on chemical tests and tests for cations using aqueous sodium hydroxide solution and aqueous ammonium hydroxide solutions. That looks into that in more detail. Okay, so these hydroxides are insoluble. There's just one further thing that I'm going to add with regard to aluminium and also zinc, and that is that their hydroxides, like their oxides, are amphoteric. So what that means is that the hydroxide has both acidic and basic properties, which means that it will react with both an acid and also a base or an alkali. So we're very familiar with hydroxides reacting with acids because hydroxides tend to be normally alkaline or basic, but not so familiar with hydroxides reacting with alkalis or with bases. But this is the case, for example, with aluminium hydroxide and also with zinc hydroxide. So if I add sodium hydroxide to aluminium hydroxide, then it will dissolve, forming an aqueous solution of sodium aluminium tetrahydroxide. Okay, now where will you have seen this? Well, you will remember that this is one of the tests for the aluminium cation, that if we have an aluminium salt, then we add sodium hydroxide to that salt and we form a white precipitate of aluminium hydroxide. Okay, and then you'll remember that what you then do to demonstrate that it's aluminium, for example, rather than calcium, okay, you then add extra sodium hydroxide. You add excess sodium hydroxide, and that then will redissolve the aluminium hydroxide because this aluminium hydroxide is an amphoteric hydroxide forming this solution. So the aluminium hydroxide redissolves in excess. Anyway, if you want to find out more about that, then you can go and have a look at the chemical tests as I mentioned earlier.